Okay. So I chose my telescope to be the W.M.Keck Observatory, the Keck telescopes. So, yeah. Why did I choose this telescope? The reason I chose this telescope was because I was really intrigued on like the unique design and the amount it weighed and how big it was really. So it was 10 meters and 10 meters long, 8 stories, and it was a 300-ton telescope, which is crazy to me. And the design of it is super unique. So each primary mirror is composed of 36 hexagonal segments that work together as one single piece of glass. And so like the size of that just like shocked me really because although like it was like created in 1985, it was like it's still like one of the biggest telescopes there is today. So and it is still the world's largest optical and infrared telescopes. Okay, so the location. Most of the best ground-based observatories are located on mountains for several different reasons. For one, starlight appears less distorted in the thin atmosphere on mountaintops. Two, at high altitudes, there's like less atmosphere to absorb like the infrared energy, and um, it reveals like the details about some of the coldest objects in the universe. So, oh yeah, also the mountaintops have unobstructed views of the horizon in all directions, and there's like not really like if you're on a mountaintop, there's nothing that's gonna block your view or anything like that, so you don't have to worry about anything getting into your view. So the W.M. Keck Observatory reaches those desires as it stands at an elevation of 13,600 feet near the summit of Mauna Kea in the U.S. state of Hawaii, which is a volcano. So, and even though the telescope was made in 1985 or started to be made in 1985, even though it was finished in 1996, it still remains the third. So there's two telescopes, the Keck 1 and the Keck 2, and they still remain the third and the fourth largest telescopes in the world, although it was made like 20, 30 years ago. So the telescope's located on top of a volcano, and because it's so close to the equator, Mauna Kea, which is where the telescopes are, it makes a perfect astronomical observation site because it's so close to the equator. So when was it built? The construction of the W.M. Keck Observatory began in September of 1985 from the help of Howard B. Keck, who gave $70 million to fund the construction of the observatory. So in total, they received $155 million of like donations to help construct both of the telescopes. But of course, since Howard B. Keck gave $70 million, the telescopes were named after him because without all of that money, it probably wouldn't have been possible. So the first light occurred on the 24th of November in 1990, was when it was finished, the first light. And it only had 9 of the eventual 36 segments, the mirrors, that all work together as one piece, the glass. And the second light started to be constructed in 1991, 1 year after the first light was completely finished. That's basically it for when they were built. And well, the Keck 2 finished 1996, October 23rd. So main obstacles. So one big obstacle that was happening for telescopes was that the atmosphere changes so quickly, and so it was hard to get like solid, clear results due to like the atmosphere changing so fastly. So the two Keck telescopes were good at getting clear results due to the fact that the telescopes were able to alter its mirrors 2,000 times each second, which made the results 10 times more clear than it usually be without their system, without the Keck system they used. And they made a change that, like, the change helped the telescopes. The telescopes could change rapidly as well, along with the atmosphere. So it basically just cleared up the results, which was great for the whole all the telescopes. So Optic mirror specs, the reflector dash refractor. Since the Keck telescopes use mirrors to gather and focus light, it's labeled as a reflecting telescope, not a refracting telescope. Okay, so the aperture size. The primary mirror comprises of 36 hexagonal segments, each 1.8 meters across the corners. The maximum diameter of the primary mirror is 10.95 meters, and its focal length 17.5 meters. The telescope aperture area is equivalent to that with a circular aperture, 9.96 meters in diameter. So it's pretty big. So the optical diagram. Okay, the optical diagram. Keck telescope specifications. So I'm gonna list really quick. The optical design is called the Ritchie creation. The overall height is 24.6 meters. And what interested me the most was, like I said earlier, like the weight and the size of it. So the total moving weight of it was 370 tons, which is crazy to me. Like, that's just extreme, like that's so big. Plus the total weight of just the glass, just the 36 segments of glass, was 14.4 tons. So it just shows you how big it really is, how heavy it really is. Then I have a picture of the optical diagram where it just shows the secondary and primary mirror, and it gives you a good look of the 36 segment primary mirrors at the bottom of the telescope. And yeah, that's basically it for the diagram picture. So the instruments, the imager, the Keck Cosmic Web Imager. It was designed to provide visible band integral field spectroscopy with moderate to high spectral resolution, various fields of view and image resolution formats, and excellent sky subtraction. The spectrograph. It's the low resolution imaging spectrograph. It's a low light instrument capable of taking spectra and images of the farthest known objects in the whole entire universe. So it really gets a good, clear image of even the far objects in the universe, and has the ability to explore stellar populations in distant galaxies and galactic clusters. Then the coronagraph. The NIRC2 vortex coronagraph is an instrument of the Keck 2 designed to directly image exoplanets in circular disks at mid-infrared bands. So the exoplanets. Using the Keck telescopes, astronomers found an exoplanet around a star by detecting a gravitational tug a planet creates while being whipped around the star, which was like really cool news at the time. Even now, that's very cool. This was the first, because it was the first independent confirmation of a planet, and it was because of the Keck telescopes. So the star research. In 2012, UCLA astronomers, while using the Keck telescope, found an intriguing star that orbits around an enormous black hole at the center of the Milky Way. It occurred to be the shortest known orbit of any star near the black hole. And this was pretty cool because it could help us prove whether or not the Albert Einstein prediction about the black holes is true or not. It can help us discover new things like that. And so galaxy research, the Keck telescopes have helped a lot when it comes down to figure out information about our telescopes, especially because it helped us figure out that our galaxy is almost entirely made out of dark matter, and it also uncovered 4 quasars in a single system. Cosmology. Due to the help from the W.M.Keck Observatory Adaptive Octave System, a group of astronomers led by the University of California were able to discover that the universe is expanding more rapidly than previously thought. So like the team, like basically, so like at the beginning the universe was expanding super fast, and then it slowed down due to the gravitational pull of dark matter. So now that they realized, due to the Keck telescopes, that the expansion is speeding back up again because of dark energy, but like we still don't know why, like what the force is creating. So basically that's it. Cool. So there's some cool pictures at the end, some cool discoveries, and yeah, that's my presentation about the Keck telescopes. Thank you.